Stiamo per partire su Lasagne. Welcome everybody. Welcome to the first talk of the day on track Lasagne. Our first speaker today is going to be Steve. Welcome. Steve is going to give us some tips on how to refactor Python code. Steve?
Morning. Hopefully we all know what refactoring is supposed to be. Anyone who doesn't? Good. According to the dictionary definition, refactoring is when you take your time out to make your code neater, tidier, more maintainable. And unfortunately, in the real world, you very rarely get a chance to do it. Because there's always a project manager who's watching over you, making sure you're spending your time actually working, as he puts it, not messing about. So we often have to try and do a little bit of refactoring as we go along. And this is essentially what incremental refactoring is doing. We have to try and sneak in tidying up of the code as we add features or fix bugs. Hopefully everyone can see the slides okay. Right, so the aim of our refactoring is more maintainable code, more efficient code, and code you'll admit to, code that you'll actually be proud to put your name on rather than wishing someone else's name was on it. For incremental refactoring, we have to do it in small steps, and most important, since we're normally doing it behind someone's back, we have to be able to say, have someone come along and say, we need to deliver the code right now, and go, yep, fine, here you go. Right. Now, maintainability. We've all seen code that works fine, quite happy with it when we finish writing it, or someone else was quite happy with it when they finished writing it, but come back to it in 6 months or a year or 5 years, you go, what the hell was I doing? Who on earth thought of this? And it takes a long time to actually work out what you're doing. While we're in the process of refactoring, we can normally make the code more efficient, get rid of redundant statements, consider other slightly different ways of doing things that are going to be faster as well as prettier. And you often find that you've got things in your code that work fine on, say, Windows XP, but not on anything else, especially if you've been writing the code for Windows. So we can aim for it to be more portable, more cross-platform as part of our refactoring effort. The other thing that's fairly important is that if you're using a cross-platform user interface like WX or Tinker, then you might be happy with the look and feel. Then someone else comes along and goes, no, I need this to work from the command line. Or I want to work on something that your particular user interface library doesn't support. And that can be quite a challenge if you've not refactored your code considering that sort of thing. Okay, and apologies to our hosts. A lot of first pass code is often referred to as spaghetti code. Following from one point in the code through to another is an absolute nightmare. You jump all over the place in one big file and you just can't keep track of where you are. But an awful lot of code is actually like it's been through a blender. You've got a little bit of GUI, a little bit of data, a little bit of functional, a little bit more GUI, a little bit of functional, and you're jumping all over the place, even within one function. You might find that you're both manipulating data and updating GUI. And can come to do something like changing from one user interface library to another. Going to be changing everything, every function, or at least looking at every function to try and do it. That's the sort of thing you want to try and avoid. So, incremental refactoring. Frankly, it's easier to do. If you actually sit down and try and prize the whole program apart and fix everything at once, might as well just bin the whole thing and start again. It's probably going to be quicker. Not an easy process to do a major refactoring, especially when you get interruptions such as, oh, we need to deliver this in an hour's time. And you do need to be able to, again, in the real world, people come along and say, oh, that code you were writing, I need it now. Or usually, I needed it yesterday. Obviously, when that happens, you have to say, well, it's not as good as I'd like it, but here it is. It will work, or it will work with these limitations. And frankly, if you try and tell your project manager that you've got to take 2 days or a week out of a project to do some refactoring, he'll hit the roof. He will not be happy. If you've, in the process of fixing a bug, instead of spending 2 hours fixing the bug, spend an hour refactoring to get the bug into one separate unit and adding tests, then fix the bug. Probably take you about the same time as just fixing the bug in the original code. As the project manager doesn't know any different. You can always tell him, oh, I had to isolate it before I could fix it. Right. Ideally, we never need to refactor because we write perfect code. Or better yet, we refactor all the time as we're going along. Often we don't get that chance. When we're in a bug fixing session, as I said, it's a good time to do it. When you stumble across some code in the process of looking at something else because you're adding a feature that's particularly bad, nice idea to try and fix it. And the same if you're adding an enhancement or just get a chance, get a spare 20 minutes, no one's looking. An awful lot of project managers, if you're actually busy at your desk typing away, they'll be quite happy that you're actually doing something. Okay, so things to consider when you're setting out to do some refactoring. Obviously, most likely scope is when you've got a big file. I had a project recently that I was asked to review where all the code was in one 9,000 line file. Fairly obvious where to start. Can't cope unless you're actually currently right in the middle of writing that big file, that sort of size of code in one lump. Bound to be causing problems. Obviously, if there's an area where there's bugs, that's a good candidate for some refactoring. You can strictly said refactoring is not supposed to change the functionality of the code. Unless you're in an academic institution or a pure software institution, probably won't get away with that. So where there's bugs is a good place to look. Areas that there's a need for enhancement. Anywhere we've got a mixture of data, processing and user interface all in one thing. We all know it's a good idea to keep them separate. But when you're doing it, oh, let's just update that while I'm doing this, it's very tempting. And PyLint, various other tools such as Pepe can be very, very handy for pointing out areas that you need to address. Obviously, when you get PyLint out of the box, it tends to report thousands of errors of, I don't like the naming convention you've used. And that hides the trees in the forest. Spend some time configuring PyLint on your machine and get it used to your coding conventions. Lovely one is that by default it doesn't actually like n as a loop increment. Tends to be one of the ones that almost everyone uses, and insisting on all capitals on anything that's at file scope, including everything in your test code, which, again, a bit of tuning and it will stop reporting all those. It's better to actually tune it, give it the wildcards to say these are valid names than just turn off report bad names. Because, again, you'll find code that temporary objects have got 20-letter names and the actual critical ones are only 3 letters. 1. Hopefully PyLint will moan about. But it'll certainly give you some good pointers of where to start, and hopefully your refactored code will pass it through. Okay, some steps on how to do it. First, don't tell the project manager you're doing it. That he's going to get quite annoyed, probably tell you to stop it, and as far as he's concerned, refactoring doesn't actually give him any value. First thing, before you do anything else, make sure everything's backed up. Making changes, and you need to be able to get back to where you were. So, you need to deliver it right now. You can do. Ideally, your backup will be in something like SVN or any of the revision control systems where you can revert back. But if worst comes to the worst, just a zip or a tar of all your project lets you get back to where you were. Identify the areas that are best candidates for refactoring. Obviously, if you've got an area that's very long chunk of code with lots of bugs in it, or lots of potential bugs in it, refactoring that is going to please the project manager the most because you can point to bugs that have disappeared. And trying to look for partitioning of data, functionality, and user interface. Simplify matters when you need to switch user interfaces. I've had quite a few projects where they went, we've decided we don't like that look, or one particular customer doesn't like that look. Also, you'll find that when you've got your data and your code separated out, you suddenly find, hey, it's more useful. I can use that code and that data, not with the GUI, but as a component for something else. Probably teaching everyone to suck heads here, but it's fairly important to consider that all the time. Bear it in mind. If you're going to pick one section to address, so don't try and fix everything at once. Never works very well. Always get lost, or get to a point where you're so far into it, you can't break off when you need to. Okay, so, again, can't emphasize enough, make sure you've got backups. Don't mention that you're doing it. Then start by creating a new file or module and adding your standard header in before you start. Even if you're playing around thinking this may not go anywhere, you've got your standard headers in. When you need them, they're there. All your SVN traceability tags and that sort of thing. And it's quite easy to keep a separate file called maybe template that you start from and use. But first off, just start with just a copy of the chunk of code you're considering refactoring, and again, back up. Before you do any changes to the code, unless they're really obvious ones, Work adding tests. You can add tests into your separate refactored module so it will run as a standalone test module. Speak with the bugs that you know are there. Hopefully you'll get your tests to show up the bugs that you know are there. If they don't, add more tests. We haven't changed any code. But we've split out some code into a separate testable module. It's a point that we can start improving from. And you can know that you've made the improvements. Then fix your module, fix the tests that are failing. Not by changing the tests, by changing the code and doing any obvious needed refactoring, giving sensible names to things else. And likewise, if you're supposed to be adding functionality at that point rather than just fixing bugs, hopefully your tests will show the lack of functionality and afterwards will show the new functionality working. You often find these standalone little modules come in useful elsewhere. If you're doing it well, you've identified things that are going to be affecting lots of areas, and you suddenly think, hang on, I can use that over here as well. Now, having got a standalone module and tested it, I want to either comment out the original source code. What my tendency is for the original chunk to be one function or one class, and then to just rename the original file that functional class, adding a silly prefix to it, then import our new module and start using it. And then test it as an integration test. Make sure it's actually all working the way you want to for just that piece of code. And have a quick play around with everything else. Make sure you haven't broken something else. I've come across some large projects where there were actually 3 or 4 functions or objects with the same identifier. Haven't spotted them. Might be changing some code that's actually never been called. That can be a little embarrassing. A few hours work and no difference. Once you've got to that stage, you want to take a new backup. That's not overwriting your old backup. It's either a new backup or a new check-in in your revision control system that you can say, right, I've got to a point that I'm happy, it's an improvement with what we had before. Now if the project manager comes along and says, I need you to deliver now, you can say, yeah, here it is. Oh, what have you changed? Right, here's the tests, here's the test results. Here's your old version. Look, it all goes horribly wrong here. Let's do the same on the new version. Look, it's better. Never claim it's perfect, it won't be. There's always something you could improve. Don't tell him, tell him that you've improved it. In fact, brag about each improvement. At least to the project manager. Report it. Say, hey, yeah, I've spent the last hour, week, day, week getting rid of this problem. I can demonstrate I've got rid of this problem, or I've added this feature. See it. Keeps them happy that you're actually earning your wages. Then start again. Pick the next bug or feature that you want to address. The next chunk of code that's bad. And you often, after you've told the project manager, oh, you've fixed it, he says, oh, great, well, I'll tell him we can deliver. And then he goes off and doesn't come back for a day or so. You can sometimes sneak some more improvements in during that time. But hopefully, we've started off with a nice chunk of code that we're not too happy with. We've gradually made it less of a mess. And hopefully we've ended up with something that's a nice buffet where you can pick and choose. And if someone decides they want the vegetarian option, they're not going to be finding meatballs in it. Quite straightforward. Tools like lint are very useful. Use them. Test code. Useful. You run it and rerun it and keep rerunning it. Never know when one little change can have some nasty knock-ons. So basically, at that point, we go back to identifying what we can fix or improve. I promised you a couple of tricks other than general practices. This is a little class I came up with doing some refactoring called Remora. It's fairly readable. How's that? And everyone able to more or less see what's going on there? Now, one of the problems you tend to have when you're trying to separate out a chunk of code into a new file is either there'll be globals, you've got a file scope in your huge great file, or there'll be codes that are members of the single class that your 5,000 or 9,000 line file defines. Yeah, bit of a problem for finding them. Sometimes they're locals that are overwritten again and again. So tools like grep might not be that much help. So I came up with this little class called Remora. The idea is it sits on the belly of another class and cleans up a bit for it. So what we've got, default constructor doesn't do a lot. And we've got find class of property. And that works its way through the ancestors of your new class. For anything that's got a parent, actually trying to locate class that you're not looking for. So, that's going to try and locate where a particular property lives, working up through the tree. So you've separated your code out, made a new child class, and you can set that up. Get the property, fairly straightforward, tries to find it. If it finds it, returns returns it. Otherwise, it gives you a debug message. That will let you find out where you've not got anything that's traceable. Get multiple properties. Same thing for a whole group. Taking a list of properties, locating them all, and returns them as a list. Or if you want to make all those properties members of self, multiple properties to self, that will run through, and by the time it's finished, all of your items in your list will be self dot. And we have set property, same sort of way, and it works its way up until it finds the closest class above you that's got property name, and sets it. An example, some code that makes use of that from that large piece of refactoring I mentioned I had to do a little while back was this set config panel. There was an awful lot of mixture of GUI, data, control states. It was a distinct mess. One of the items I decided to separate out was a page used to set the config of the target hardware. I made that as being a child of panel, be a child of Remora. Actually get and set various items. Most important of all, a class. Bit of code. Actually let me run it as a standalone without having to put passwords in, without having to do all the various values. Dummy comms class that instead of actually sending messages to the target hardware, prints them out so I can see that the right messages are being sent at the times that we want. Default operating mode to engineering mode, which normally within the actual application I'd have had to have set 2 separate passwords and clicked a couple of different menu items before I got there. So I get straight in and make sure this one panel is looking good, the layout's working, the sizing's working. One of the fun bits with the code that the other person I hasten to add, rather than me, had written was they hadn't used sizes at all. They'd actually got everything with absolute positioning. So it worked fine on their screen, but not on anyone else's. Best of all, they'd actually got an enhancement request that was marked as not being filled yet, that the code should run on the customer's system. Never understood why that wasn't a bug, but I actually managed to get to the point where I was actually originally asked just to review it before delivery while they were waiting for some hardware fixes to be put in. And wasn't very favourable. Questions on this? No?
Right, thank you very much. We have a bit of time left for Q&A. There you go.
I'm not sure if I counted correctly, but you mentioned backing up at least 6 times in your slides. So it sounds a bit weird because I hope all of us using like Git or Mercurial or something like that. Why having to back up all the time?
Well, using Perl, using Git or SVN is one of the methods of backing up. But if you make a lot of changes between commits, another version of backing up, then while you only have a single change in version number, you tend to get caught where you can either go back to very old code, where you've lost a lot of your changes, or you've got to finish the change you're in the middle of before you could deliver the code. Do the atomic commits where you say, this is one bug, I'll fix that one bug, I'll commit that one bug's fix, then you're able to say, literally at a drop of a hat, say, I'm in the middle of fixing another bug, but you can have the version before that's fixed all the bugs that I've told you I've fixed, up until then, or added all the features that maybe they're not as pretty as I'd like yet. Rather than when the project manager comes along and says, I need to deliver that code now, you're saying, oh, well, come back in 2 hours. I might have finished by then. Or you're going to have the buggy code you started with.
Isn't it rather a depressing view of project managers? I mean, it's a bit like working for a head gardener who doesn't believe in weeding, and you have to sort of fit the weeding in surreptitiously when he's not looking. Is there not possible to persuade your project manager that actually refactoring might be a good idea?
If you work for a company that's got a strong software basis, you might be able to succeed on that. I've found in practice that if you try and tell a project manager or someone with project responsibilities, even if they've got an engineering background themselves, unless you're working for something like an open source foundation company or a pure software company, or of course in academia, then it's all the project leads got to show results per dollar. And code that does exactly what it did before, but prettier, doesn't actually add any but points per dollar. So he tends to frown on it. He might even say, it's a very good idea, I wish we had time. But
a comment and a question about the backups. You might even consider making a specific tag in your source control version if you said this is good. But my question is, have you ever looked at the module called rope? It's actually pretty useful for refactoring, and it will do a lot of finding references and stuff here. It's not perfect, but it's often useful.
yeah, it's not perfect. The IDE that I'm currently using here does actually have some refactoring tools for things like renaming all instances, and it tries to identify which are actually relevant instances. But as you say, they're not perfect, and every time I've tried, I'll move this to a new file, it was with mixed results. The most important thing, as far as I'm concerned, is tools like Rope will separate the code out, but they don't add any testing, and they don't make it a standalone testable module, which I think is very important. Then say, right, that is one bug, I've isolated it, I've tested it, I've fixed it. And actually gives you quite a nice feeling when you can say that.
Any other questions? A small tip of my own could be the fact that you could actually create, when we do refactoring, we create local branches, okay, so where you can refactor and then you can commit, and anything you commit on the local branch can then be or reintegrated into the master branch, or it can even be thrown away, because anyway it's not published anywhere. A tip I would give, and please tell me if I'm wrong, is the fact to branch off, do the refactoring, and in that same moment you have a copy of code which is not refactored and working, and a copy of the code which is to be refactored. Once that is done, you can pull it back in, so merge it back into the master branch, and in case you do changes to the master branch, you then pull them back into the refactoring branch.
Oh yeah, that's very important, providing you've got a revision control system
Yes.
in place. I've worked quite a few companies where they didn't have. Several of them I managed to actually persuade them it was a good idea and get them in, especially when I told them, hey, there's ones that are available for free.
Yeah. But the good thing about Git is that you can actually create it without publishing it. You can
Yeah.
create local repository.
And remove it again with Git.
Yes.
I could add to this that even the coolest part of Git is that you can commit as often as you wish, and if you want to deliver the one single commit for a feature, you can then rebase them interactively to the single commit.
Yeah, very true. Unfortunately, the company I'm currently contracting at, while we've managed to find a way of getting SVN in through the back door. The IT department won't let us use Git. They don't trust it. Talks on the, I don't think they understand it. A corporate outsourced IT department, they actually tried to get all the developers to sign an undertaking that they wouldn't produce any back files, executable code, scripts. I mean, hang on, we're developing software. This is our job. No, you're only allowed to run Word. And you're not allowed to actually have macros in Word. It took a lot of arguing to get them to let us actually run anything else but Office Suite.
Hello? Just a joke, but aren't you worried to work in collaboration with people that don't understand revision control, refactoring, and wouldn't you escape from these kind of guys who are so...
I would love to. I would love to. Some of the people who there are issues with are inexperienced, and when you show them the results, they will learn. Some of them are very experienced, and no matter how often they're shown, they like to stay working the way that they were working. I was actually on a project a little while back where we had an outside firm come in to test the project, and they froze the source code in the revision control system at a particular revision to say, right, we're starting our testing from this point, and did that on the Friday. They came in the Monday to find that the lead engineer had overwritten over 200 files with changes that he'd actually got on his home system that he'd been keeping to himself, and wiped out their lock of the system. And he was the lead engineer. Worrying.
Any other questions? All right. Thank you very much, Steve.
Right, thank you. Yeah.
Locally, I use millions of projects and publish probably a tenth of them.